Here is a combined summary of the 4 pages. This paper introduces Train-Attention-Augmented Language Model, TAALM, a novel approach to continual knowledge learning, (CKL), in large language models. CKL aims to mitigate catastrophic forgetting by focusing learning efforts on important tokens. TAALM predicts weights of each token based on their usefulness, leveraging this weight on the training phase to enable efficient update of new knowledge. The supportive model, Train-Attention, predicts weight for the base model through a metalearning framework. The authors also introduce a new CKL benchmark, LAMA-ckl, designed to offer a more clear comparison of learning and retention performance. Experiments conducted on LAMA-ckl and previous CKL benchmark, Temporal Wiki, show that TAALM achieves remarkable state-of-the-art performance on both. Continual knowledge learning is a variation of continual learning that focuses on updating new knowledge without catastrophic forgetting of previously learned and preservable knowledge. The proposed methodology assigns weights to log probabilities of each sequence, approximating the importance of each sequence, named token importance. Token importance is defined as usefulness, indicating how much the contained information is useful for solving related tasks in the future. The medal earner, Train-Attention, predicts the optimal token weights. The training process involves learning knowledge and solving a task, described in 2 steps: learning and solving. The revised model is applied to solve the task, and the loss value is computed to quantify the performance. The optimization of Train-Attention involves sampling a data pair, predicting weights, and updating the base model and Train-Attention through multiple iterations. The research paper presents a novel approach to improving the continuous knowledge learning capabilities of large language models. It introduces Train-Attention-Augmented Language Model, TAALM, which utilizes a medal earner to generate token weights for efficient learning. The authors also propose a new benchmark, LAMA-ckl, tailored from the LAMA dataset to assess plasticity and stability in CKL tasks. The medal earner, named Train-Attention, is trained using a task weight learner, TWL, method that adapts the token weights based on task performance. The authors conduct experiments on 2 benchmarks, LAMA-ckl and Temporal Wiki, and demonstrate that TAALM outperforms other baselines in terms of ability and speed of learning, achieving substantial improvements in CKL performance. The results show a considerable balance between stability and plasticity, making it a promising approach for future research and continual learning. The research paper presents a novel method, Train-Attention, to enhance the performance of continual knowledge learning, CKL, in large language models. It demonstrates significant improvements in CKL performance and synergy with other baselines. The authors analyze the contrast between plasticity and stability, showing why their method, LAMA-ckl, is more effective than traditional methods. Experiments on QLORA-based and K-adapter-based models achieve state-of-the-art performance across all periods and both changed and unchanged TWIKIPROBES. The paper discusses limitations and potential for future exploration, including task specificity and broader impacts on enhancing the practicality of large language models. The authors also detailed the LAMA-ckl benchmark, a dataset designed to evaluate the ability of language models to learn and retain knowledge over time, including its setup, criteria for selecting documents, and statistics for the TOLEARN and NOTTOFORGET sets. Here is a combined summary of the content from pages 13–16. This research paper focuses on the relations between NOTTOFORGET and TOLEARN sets, evaluation setup, and Train-Attention training details. The NOTTOFORGET set includes 17 relations, such as place of birth and country of citizenship, while the TOLEARN set consists of 13 relations, including instance of and position held. The evaluation setup utilizes 8 RTX 3090 GPUs with a global batch size of 64, learning rate of 1E4, Atom W optimizer, and max length of 512 tokens. The authors employ a novel Train-Attention training approach, selecting LAMA units with an accuracy below 0.5, resulting in a dataset of 4,166 units. The authors trained small and large models from the LAMA family, integrated with QLORA, and find that using a large model for the base model results in faster convergence. They adopt a large model for the base model and a small model for the train attention model. The train attention head is initialized using a normal distribution, and the weights generated are equivalent to uniform weights. Experimental results show that the proposed TAALM method outperforms large baselines, even when combined with other baselines. The combination of TAALM and MixerView achieves the highest top ACC and total knowledge. The trade-off between plasticity and stability of all baselines is presented, with variations combined with the proposed method positioned in the upper right quadrant, signifying minimal trade-off between updating and forgetting. Error ranges of the main experiment demonstrate the consistent performance of the proposed method. The research paper presents a comprehensive analysis of the trade-off between plasticity and stability in language models, utilizing the LAMA-ckl dataset. It visualizes this trade-off through various figures, including Figure 13, which compares baseline models, and Figure 14, which showcases the performance of large-scale baseline models over 30 epochs. The paper also introduces the concept of descriptive and schematic forms for the LAMA dataset, proposing the use of the schematic form for better alignment with causal language models. The study adopts the LAMA-ckl task format to handle grammatical violations and employs heuristic filtering to remove empty texts. Experimental results on Temporal Wiki show that performances mostly move in the same direction when baselines are trained on the DIFFSET of each period, suggesting that LAMA-ckl is a better benchmark for observing the trade-off between plasticity and stability. The paper also presents tables and figures detailing the portion of task sentences with evidence documents and the experimental results of small baselines on the Temporal Wiki benchmark.